I'm actually a computer scientist, so this is quite relevant to me, and I feel quite good chairing this session. So we will have 3 presentations featuring studies that have a heavy use of machine learning or AI tools for gesture studies. The first one will be on automatic annotation and recognition of gestures. Second one will be the impact of gestures in the perception of creative linguistic constructions by human and avatars. And the third one will be about formal and automatic building of gesture representations or features. So without further ado, let's start with the first speaker. Kate, please.
Hello, good afternoon. My name is Kate Carter, and I am with the Cognitive Science Department of Case Western Reserve University. My lab is the Red Hen Lab, and for those of you who are not familiar with our work, we collect multimodal communication data, mostly in the form of television broadcasts. So we have over 300,000 hours of natural language speaking with gesture, and this is across, I believe, 14 languages. So we have all of this data, and we have some very advanced tools for analyzing the speech and actor detection in the data that has been pioneered by my PI, Mark Turner, and other senior members of the lab. But we have this problem of not being able to create large data sets that are annotated for gesture. And this we would like to study very much. And so this is where my project has come from. It is aiming to create tools that can be used to create large data sets to apply large data analysis to co-speech gesture. So to do my research, I used the Gemini API. I had no hand in developing the API, but I have written some scripts around it and developed a data set to test how well Gemini can recognize co-speech gesture. 6 weeks ago, the functionality of multimodal transformers was eclipsed by the growing multimodality of generative AI. Gemini in particular, the model 2.5, is something called a multiplicity of experts, which means that when an input is sent up, it detects what the modality is, whether this is speech, whether this is a video, and then it sends it to either a visual transformer, an audio encoder, the like, which then creates a CSV file that can be interpreted by the large language model. This then sends back down the inputs to me, and I'm able to analyze it. So I started with a data set created by Dr. Peter Uhrig on the Ellen DeGeneres show, which is between 1 and 6 minutes long. Each of these clips contains native English speakers gesturing in a interview format and has multiple gestures and actors per clip. Because this data set was originally designed to work with transformers, they're unable to temporally annotate gesture, so I manually chopped this data set down into 99 0.7 to 5.3 second clips, each containing one actor performing one gesture. This was then combined with Python scripting that gave a prompt and, in some trials, a context document to Gemini. It was sent up into the cloud for analysis. And then I sat down at my computer and I manually verified how well Gemini performed on each of these clips. And then I made some pretty pictures for you all. So this is an example of an input gesture that I used.
Everybody's got things that they're going through and people that are here. And
as you can see, this is a very complex set of gestures. It is several beats and also seems to be somewhat metaphoric.
That everybody's got things that they're going through and people that are here.
And also there is audio accompanying it. So this is my analysis prompt. I instructed Gemini to analyze the co-speech gesture in the video in 2 sections, giving an action performance analysis because this was something that Gemini was already known to do. It is very good at describing the actions in a video and also task descriptions. And then I asked it to give me the co-speech gesture category that it belongs to, either a beat, didactic, iconic, etc. I used etc. mostly so that it knew there were other options than the ones that I gave it. And then if a gesture was metaphoric or iconic, I asked it to provide a subcategory or a description. And this is what I got out. Now, as you can see, there are multiple timestamps and multiple actions being described. This was spontaneous. I was only expecting it to give me one timestamp, one description, and one gesture. So this is an example from one of my 2.5 trials, which is Google's newest model. It was released on May 20th. And this is describing the action that we saw in the previous clip. So it's giving a description, it's giving a category of metaphoric regulator, and then it is also giving a category, a stop or a hold on gesture. What is interesting about this is that it is giving multiple timestamps with multiple categories and a very in-depth description. I have verified the timestamps to within 1/10 of a second accuracy, and it also is spontaneously pulling from the video transcript, which I did not ask it to do. So in my trials, I had 4 conditions. I tested Gemini 2.0 Flash, which was released in March of 2025. I also tested Gemini 2.5 Pro Preview, which was released on May 20th. And then they were either given no context, just the prompt and the video, or they were given a PDF of McNeil 1992, What Gesture Reveals About Thought. I looked long and hard for the best classification document to give it. This was what I came back with that was free and available to me, and also not a book. I wanted something that was relatively short because these models get less accurate the more that you give them. So what I found is that Gemini 2.0 very reliably gave an answer. Less reliably, it gave a correct answer. And it was not able to timestamp. Gemini 2.5 Pro had more failure, so about 50% of the time that I gave it a video, it did not give me anything back, which took much longer. However, it gave very, very accurate timestamps, and it also was able to recognize multiple gestures. So these are my results. This is a heat map showing the accuracy per gesture category that the model was asked to identify. You can see in this first column, 2.0 no context, it is very inaccurate. The reason for this, I believe, is that it was trained on papers that were not linguistic. It had a high instance of telling me that something was an illustrator, which is a psychological term that is used for gesture study, but is not particularly relevant to us linguists. When I gave it context, it got much better at recognizing metaphoric gesture. And then, interestingly, 2.5 was my most accurate model, and then when I gave it context, it actually got worse. I do not have an answer for this. I will have to test it further. But I have no access to what this model was trained on. The only thing that I have access to is what I have given it. So it is very impressive how rapidly this technology is improving. Going from 26.9% accuracy at recognizing metaphoric gesture to 80% is quite a jump in one release. So the exciting thing, perhaps, for this technology is not where it is right now, but where it will be in 3 months. However, it is very, very good at timestamping. As you can see, 2.5 without context was not as accurate. It became more accurate when context was given, and I would chalk this up to it having instruction for what to look for. It has more of an idea what it is looking for in what is a gesture, what the start of a gesture looks like, and how this works. So we have to thank McNeil for that. But what is this useful for if it is not accurate yet? It can be used very accurately to identify one gesture, perhaps metaphoric, and so it can identify where in a transcript the gesture is, and then you as a researcher can go and look and say, okay, yes, this is correct. If it identifies something that it is less good at, then it might need to be checked. But it's very good at movement description and identification of a single gesture. When you move to 2.5, which is more equipped for multimodality, you get into very accurate time stamping, which can be used to translate into Elan and eliminate the time that a researcher has to go searching through the data set for something. And it is also good at the speech gesture correlation for iconic and metaphoric gesture. What this means is that it can tell you very accurately what words co-occur with a gesture. And then expected use case for following generations. We are probably looking at within 2 to 3 generations, the ability to use this software to fully automatically create large data sets for gesture study. What this will probably look like when I'm finished with my Python scripting is that you can feed in videos and it will pop out in Elan with the gestures marked in Elan how long they are, as well as several tiers for what the gesture is and then possibly a category. So it is able to say, this is a metaphoric gesture, this seems to be a spatial gesture, and it seems like a proximal space or a distal space, or maybe this is a temporal gesture. It is very good at recognizing what concept, based on the speech and the gesture that is present, that this gesture is supposed to represent, which is incredible. It will most likely also be able to autonomously recognize multiple gestures in one clip and do this Elan annotation, which will frankly be a relief that I do not have to spend time searching. This is a pilot study. I put this together in 3 months of manually verifying 400 data points. And so I would like to next look at tailored context document that has clear updated classification standards that are meant for an AI to read. McNeil is fantastic. I do think we have come a long way since him in terms of how we classify gesture and how we can instruct the artificial intelligence to help us reduce the manual labor with doing this. I would like to look at longer videos with multiple gestures and actors to see if it holds its ability when there are more things going on. And to do this, I will take the original data set that has not been chopped to one actor, one gesture, and feed it into Gemini. And then the next step will be asking it to create this Elan file, more likely asking it to create a CSV file and then using a Python script to translate this to an Elan file. And this will allow for the creation of data sets which we know what they look like, which we are familiar with. It can be used to reduce a lot of the work in the data set creation so that we may spend more time working with the data itself in a format that is comfortable and easy to work with. So my goal with this project is to create a tool for us to use. And the beautiful thing about working with Gemini is that you do not need an HPC. You do not need to have very much technical knowledge. It is free and available for anyone to use. You just have to download the script, plug in the videos that you wish to analyze, and press go. And it will give you a result. And I find this very exciting. So thank you very much to Peter Ulrich for creating my original data set and for the support that I have received from Red Hen throughout this project. Thank you to the Google API team for making this resource available to the public. And if you would like to read my project blog or my references, there is a a nice QR code for you. And thank you very much to the interpreters that I'm working with today to make this talk accessible to all of us.
Thank you very much. That was very nice talk. Now I understand why you have 4 PhD offers. So we have 5 minutes for questions.
Young people first.
Yeah.
You in the
We
middle?
have.
Yeah. So can you hear me?
Yeah.
Okay, I have.
No. Yes.
Yes, they have a microphone for you.
Yeah, I was wondering. I didn't get a microphone. I have first question concerning the data protection when using Gemini, because I didn't understand how useful this tool would be for researchers in multimodality of on individual corpora, for example, of not publicly available videos like Ellen shows, but collected corpora in data sets. And the second question is because you...
Can I start with this one first?
Okay.
I'm sorry, I have a very bad memory. So in terms of using Gemini for protected data sets, our data set actually is protected. We have permission to use it for scientific purposes, but we are not allowed to distribute it at all. So in kind of a non-specific terms, I will say that my lab's legal team is okay with me doing this. I believe that the Gemini AI does not train from the videos that you upload for research purposes. And so you can go into the settings of the API, and when you get your API key, there is, I believe, an opt-out check, so that you may run your data without it being added to the corpus. This is my understanding of how it works. However, I can definitely get you the specific documentation if this is something you want to read.
Okay, thank you.
So before you ask the second question, I'd like to give opportunity to other people. If we have time, you ask your second question. Can you to show?
Thank you. This is amazing. I was especially impressed by the accuracy of timestamps, because even 2 humans cannot agree on the segmentation data. So I was wondering how you actually evaluated the interrelability on segmentation. How did you actually quantify that?
So the way that I evaluated timestamping is I have this data set in Elan, and then I would go to the section of the video that Gemini says that the gesture starts, and if it was within about 1/10 of a second that Peter or Dr. Steen or whoever originally made the data set said that this gesture started, I would say, okay, this is correct. And in my data analysis, it's a true or a false variable. It is not a exactly what the timestamp is. So when I have more time to run the statistics, I can give a better analysis of the range to which it is accurate, but currently I can say it is accurate within 1/10 of a second of when the human researcher who created the data set said it would start. Yeah.
Yes.
Thank you for the question about data protection. I think it's important to notice. I have another question about the fact that you said it's a black box. We don't know what's happening behind. And I think that's a limitation, because sometimes you want to know what the model is doing, because you can have more information as patterns, how he detects the thing. So I wanted to ask you, how do you think about this in the future? Because Google won't help you to know how the model is functioning.
Oh, for sure. It's very useful to know what's going on behind the scenes. There's actually a new model that's been released, I think, in the last week called ERNIE 4.5, which is a open source version of Gemini. So this is probably the model that I will continue my work with. However, my goal with this project was to use something that was publicly available to make a usable tool. And there is some documentation on the architecture and the training methods of Gemini. However, there is no way for me to alter or change what it is trained on. What is relevant to mention is that the context that you give the model very much informs how it will classify. So there is a lot of control that you can have through prompting and contextual documents in order to inform how the model performs classification.
Thank you. Yeah. So I think we stop with the questions. If you have other questions, you can.
Over here?
Later. No, we don't have time. We'll go already for the next presenter.
Find me afterwards.
Yes.